So let's say that there is a baton twirler who has a baton with two small balls attached to the end of a light stick. And she's just really curious. She wants to know the angular speed of the balls when she spins her baton. And let's say that somehow she knows that the kinetic energy is 2.02 joules, and that each ball is 10 grams, and that the rod itself is 1.5 meters long. So we're going to help her calculate the angular velocity of the balls. To start, we need three equations. We need to know that the radius is half the length. We need to know that the moment of inertia is the mass times the radius squared. And we need to know that for angular momentum or angular motion, the kinetic energy is 1/2 the moment of inertia times omega squared, and omega is our angular velocity. So I'm going to start by using our kinetic energy problem. And we are going to solve for omega. So omega becomes the square root of 2 times our kinetic energy divided by our moment of inertia. And what I'm going to do here is I'm going to continue to plug things in that I know until everything in my equation are things that I've been given in my problem. So I don't know moment of inertia, but I do know moment of inertia is the mass times the radius squared. So omega then becomes equal to the square root of 2 times the kinetic energy over. Now this mass is the total cumulative mass. So what I'm actually going to do is I'm going to say it's 2 times the mass of one ball. You might see why I do that in just a second here. And then it's times the radius squared. So the reason why I say 2 times the mass of one ball is these 2's will actually end up canceling. And it simplifies the math so I don't have to do extra calculation. So and then I can further simplify that by the fact that I know the radius is 1/2 the length. So then that becomes the square root of the kinetic energy over the mass, and again this is just the mass of one ball, times 1/2 the length, and all of that is squared. So the way I'm going to rewrite that, and so the square applies to the 1/2 and the length, and instead of dividing by another fraction, what I'm going to do is I'm going to take its reciprocal and multiply it. So that 1/2 becomes 1/4, and then I can bring it up to the numerator. And so that becomes 4 times the kinetic energy over the mass of one ball times the length squared. And I can simplify this even further by taking out that 4, since 4 is a perfect square. So then that our angular velocity becomes 2 times the square root of my kinetic energy over the mass times the length squared. So now I'm given my kinetic energy. I know the mass of each of the balls, and again this is just the mass of one ball, and I know the length of my rod, so I can actually calculate everything here for this. So I'm going to say that that's 2 times our kinetic energy is 2.02 joules. Now if you didn't already notice, our mass is given to us in grams, and we can't calculate that in grams. We need to calculate it in kilograms to get the appropriate angular velocity. So 10 grams is 0.01 kilograms, and then I'm going to multiply that to the length, which is 1.5 meters, and I square that, and that gives me 18.95 radians per second. And this is the angular velocity of our balls at the end of that rod.